Okay guys, so today we're going to do some math over here. We're going to be mostly talking about trigonometry and how to convert a function into a different function using the different sine, cosine, etc. So I'm just going to give out an example today. So the function is cosine 2y minus 1 over sine squared y. And we have to prove that. You know how I said prove? Because we're not solving. We're trying to prove that this function equals to negative 10 y over 1. Sorry, I just lost my mic. Let me just, okay, now better. Okay. So you can choose to go from this side and try to take it to this side, or you can go the opposite from this function to this function. I'm gonna start from the left hand side because it looks like it's complicating and I'm trying to make it into an easier function. So the left hand side is equal cosine 2y minus 1 over sine squared y. That's the left hand side. So so right there we can see that we know a function that it states that cosine 2y, I'm going to put on the screen, cosine 2y is equal to 1 minus 2 sine squared y. So we know this cosine 2y, I'm going to put the function in the pictures, it is equal to 1 minus 2 sine squared y. And obviously you have to put the minus 1, that minus 1. But that function, they said cosine 2y is equal to 1 minus 2 sine squared y. And we also know that sine squared y, we know that sine squared y is equal to 2 sine times cosine. Sorry, I meant 2 sine y and cosine y. Yeah, we know that sine squared y is equal to 2 sine y times cosine y. Since I don't have space, we're gonna start over. We're gonna start over here. So let's say the function is the same. 1 minus 2 1 minus 2 sine squared y minus 1 over 2 sine y cosine y. Since 1 minus 2 sine squared y minus 1 2 sine y cosine y. See, right here we can automatically cross the, since this is plus 1, that's minus 1, we can cross these out. So we're left with, we can cross these out, so negative 2 sine squared y over 2 sine y cosine y. We can also cross these out, but remember we have to keep the sign. we're only crossing the 2 out, we have to keep the sign. So it'd be, for we cross we have to keep the sign, cross out the number 2, it would be negative sine squared y, and we have sine y and times cosine y. So since we have negative sine squared y, that is equal to that squared y is 2y, so that is equal to, if we have sine squared y, that is equal to negative sine y times sine y. It's only one negative, because if you have another negative right here, then we multiply the negative sine y times the negative sine y, we're going to have positive. Remember how we have negative times negative equal positive, and negative times a positive equal a negative. So we have to make it negative. So it would be a negative sine times sine, which is equal to negative sine squared y. So that would be over, let's keep the same thing, sine y minus cosine y. You see how I am not, right now I am not, and I'm not solving. All I'm trying to do is I'm trying to prove if this function is equal to this function. And in this problem, it is equal, because if it's not equal, it would literally take us days to solve the. It will literally take us forever, not days, because we're not gonna find it. And I'm pretty sure most, if you were giving to prove in a function by teacher, it would most likely be it is equal to, and in this problem it is. So right now we know that we can cross out the signs, because sine over sine is 1, so we can cross these out. We're not crossing out the negative sign, no, crossing out the sign, both signs, the positive signs, both positive sign, and that is equal to negative sine y over cosine y, which is equal to negative tan negative tan y, because sine over cosine is tan, and then that's a negative sign, so it's negative tan over y. And right here we have 1, so we automatically know that anything over 1, it's equal to itself, so it would be negative tan y over 1. It is the same thing as negative tan y, and that is correct, and that's the right hand side. Yeah, that's how you do it. I hope that you found this video helpful. I am sorry if you find any background noise, and thank you very much.